Welcome to Data Do Library. In this video, we're going to talk about the Bernoulli's differential equations. Let's get started. First, let's talk about what is a Bernoulli's differential equation. Bernoulli's differential equation is going to have a form of dy dx plus some function of x times y is equal to some another function of x times y to the n. Now, this may look familiar when n is 0 or 1, it makes it a linear differential equation, which you can find a link to in the description below. If that n is anything else besides 0 and 1, it can be solved using substitution, as you'll see in the next few examples. To solve this equation, we're going to have to make that integrating factor of e to the 1 minus n times p of x dx. Again, this may look pretty familiar from the linear differential equations. Once we identify p of x, f of x, and our integrating factor u, we're going to plug it into this formula and simplify. So let's see how this works out. Example 1. X dy dx plus y is equal to x squared y squared. So the first thing we need to do is get dy dx all by itself. So I'm going to divide everything by x, giving me dy dx plus 1 over x times y is equal to x times y squared. Here you will notice that p of x is 1 over x, as the function that stands in front of x. F of x, in my case, is the function x. And n is the power of y, which in this case is 2. So now I can go ahead and find the integrating factor u. So I'm going to plug it into this formula, e to the integral of 1 minus n, which is 1 minus 2, times p of x, which we identified as 1 over x, dx, which will give me e to the negative 1 times 1 over x dx, which is nothing more than e to the negative integral of 1 over x dx, which is e to the negative natural log of x. And if you recall, the negative in front of the logarithm can be turned into an exponent, which would make it e to the natural log of x to the negative first power. And e and ln cancel each other out, and we get 1 over x, or x to the negative first power, which is 1 over x. And that is my integrating factor u. So now I'm going to go back to this formula and start plugging everything in. Y to the 1 minus n is simply y to the negative first power, because n is 2, so 1 minus 2 is negative 1, is equal to 1 over u, and u is 1 over x. We will simplify that momentarily. Times 1 minus n again, which is negative 1, times f of x, which is x, times u, which is 1 over x, dx plus c. You'll notice that we have some things we can cancel. We can cancel this x and x, giving us negative 1 as a result. We can also simplify this 1 over x. So y to the negative first power is equal to 1 divided by 1 over x is nothing more than just x, times negative 1 times 1 is negative 1 dx plus c. So y to the negative first power can just be written as 1 over y is equal to x times integral of negative 1 dx, that is just negative x, plus c. And if we just simplify this a little more, we have 1 over y distribute through, giving us negative x squared plus cx. And that is my final answer. Unless, of course, you felt compelled to write this as y equals, and in which case it would just be a reciprocal, or y is equal to 1 over negative x squared plus cx. In this example, you'll notice that it's very similar to the first example with some minor differences, especially the power there. But strongly encourage you to pause this video now and try to solve this on your own. First thing you should do is identify what you have. So next to y, notice I have p of x. Next to my y to the n power is my f of x. Notice my n in this example is negative 2. So now I'm going to find the integrating factor u is equal to e to the integral of 1 minus n, which will be 1 minus negative 2, which turns out to be 3. So negatives make a positive, times p of x, which is 1 over x dx. That would give me e to the 3 natural log of x. And as before, we will move the 3 as a power. E and ln will cancel, leaving us with x cubed being my letter u here. So now I'm going to go back into my equation here and plug in everything I know. Y to the 1 minus n power, again, is 1 minus negative 2, which is 3, is equal to 1 over u, which is 1 over x cubed, times integral of 1 minus n, which again is 3 in this example, times f of x, which is 1 over x, times u, which is x cubed dx plus c. So y cubed is equal to 1 over x cubed times the integral of 3x squared, since x and one of these cancel out, dx plus c. So y cubed is equal to 1 over x cubed times the integral of 3x squared, which we'll just do here on the side. So integral of 3x squared dx is nothing more than 3 times the integral of x squared dx, which is 3 times x cubed over 3. And the 3's cancel, and we have x cubed plus c. So we have 1/3 x cubed times x cubed plus c. Now we're just going to distribute. So y cubed is equal to 1 plus cx cubed. Let's take a look at the last example for this video. Notice the first thing we need to do is isolate dy dx. So the first thing I'm going to do is divide everything by x squared, giving me dy dx plus 1 over x squared y squared is equal to 1 over x y. Now notice this is not in this form just yet. We have y to the n power here. So what we need to do is move this around to get it into this form. So I'm going to subtract 1 over x squared y squared over to the other side, and subtract 1 over x y over back to the left side. So I have dy dx minus 1 over x y is equal to 1 over x squared negative 1 over x squared y squared. Now let's identify what we have in this equation. We have negative 1 over x being my p of x, and I have negative 1 over x squared being my f of x. And n is 2. So to find the integrating factor, I have e to the integral of 1 minus n, which is 1 minus 2, which will be negative 1. P of x is negative 1 over x dx. So we're going to simplify e to the integral of 1 over x dx is simply e to the ln of x, which, as discussed before, is nothing more than just x. So our integrating factor u is x. Now that I know that, I can go back into this equation again and start plugging everything in. So we have y to the 1 minus n, which is 1 minus 2, which is negative 1, is equal to 1 over u, and in our case u is x, times the integral of 1 minus n again, which is negative 1, times f of x, which is negative 1 over x squared, times u, which again is x dx plus c. Now we're going to simplify, so we have y to the negative first power is equal to 1 over x times the integral, two negatives make a positive, x divided by x squared is 1 over x dx plus c. So again, y to the negative first power is 1 over y is equal to 1 over x times integral of 1 over x dx, which is just natural log of x, plus c. And now we can just distribute 1 over x through the parenthesis. So we have 1 over y is equal to natural log of x over x plus c over x. I hope you found these examples helpful. Be sure to like and subscribe, and I hope to see you next time. Take care.